Good morning, everybody. Happy Tuesday. Today I'm going to be going over energy transformation and transfer. These are the same slides as the ones last week, but I wanted to talk through them more because after a live session on Canvas on Friday, I had most of my questions came from these slides. So I want to go over them, talk about them a little bit. Like I said, this week is mostly review because I did not make videos last week and because I want to give a quiz on Friday, which I'm planning on posting probably today or tomorrow, so you can complete that before Friday if you would like to. So here we go. So our ICANN statement of the day is I can explain how electricity can be transferred and transformed. So electrons can be moved through magnetic fields. This happens in three different ways. One is it transforms, it transfers, and it conserves. So conserve, that's more just a concept I'm going to be covering, and transform and transfer are very, very similar. The words are often interchangeable when we think about questions that will be asked on a fourth grade science EOG. So I'm going to be covering them and going over a couple examples. Please join us tomorrow. I plan on posting today that I'll be having a live session tomorrow night, which would be Wednesday night at 7 p.m. to answer any questions and to go through some stuff. And then I'll be doing another one on Friday. Tomorrow specifically, I'll be covering what I covered yesterday, today, and tomorrow with these videos. So I'll be answering any questions about magnetic fields, about how energy transforms, and about electrical circuits tomorrow night. Please join that. Sorry for the little tangent. Let's go back to it. So repeat after me, transform. Great, one more time, transform. Good. Next one is transfer. Great. Transfer. Awesome. And conserve. Great. So I'm going to be going through this. Think about it this way. If you were in my class and we were taking notes, these would be the three big definitions that you would want to write down today. So let's start with transfer. Transfer is the movement of energy from one location to another. Example, when electricity moves from the wall plug through a charger to the battery in your phone. So it's transferring, it's moving across different mediums. That word medium, I've used it in class before. It is a sense of like a platform or a use of something, such as like different social media platforms or mediums would be like Instagram, Twitter, Facebook, stuff like that. These are all things that use electricity, such as the wall plug, the charger, and the battery in your phone, but they're different mediums, they're different parts of things. So this is what I mean by this. If you were with me on Friday, you would know the example that I used that I thought was really great would be when you think of a toaster. So let's say it's the morning, you want to make yourself some breakfast. You know that you get electricity from the wires that go connect to wherever the power is in your neighborhood. They come underneath the ground. They go into your house and your walls, and they go to your wall plugs. Okay, so if I was making breakfast in the morning and I really, really wanted toast, I would get out my toaster, right? And I would put the bread in and I'd push it down and get ready for it to toast. But if it's not working, a big reason it's probably not working is if it's not plugged in, right? It's not going to work because I need to transfer the electricity from my wall to my toaster by plugging it into the wall outlet so it will work, okay? And that leads into our next thing, which is transform. Transform is when energy changes from one form to another. Specifically, if we go back to the toaster example, we're transferring the electricity from the wall to the toaster. And then that energy is transformed, it's changed to a different type of energy into heat energy. How do we know this? Well, we know we make toast from bread by heating the bread, right? So I transfer the electricity from the wall outlet to the toaster, where that energy was transformed into heat energy, which is used to heat the coils. If you didn't know this, in what toasts your bread is these coils who get really, really hot, and that heat is what toasts your bread, right? So we transform from electrical energy to heat energy. Another example is when you think about hydroelectricity and how we get it. Hydroelectricity or wind-powered energy. You've ever seen windmills, right? Windmills are we get energy from them when the wind blows and spins the giant turn wheel. That spinning of the wheel moves things within it to create and power energy, right? Just like a hydroelectric dam, which how we get hydroelectricity, as we know the word hydro means water. We get energy from moving water because the rushing water spins something which creates electrical energy. Like with the wind, on the windmill, the wind spins the mill and that creates energy, right? See, so as the water moves and takes in, it spins this little turbine right here, and that's what generates the electricity, right? Same with this one here. They have a turbine. That's what's the water pushing it is spinning it. Just like in a windmill, the wind pushes the turbine or the windmill and spins it, which then goes to the generator and generates the electricity. Next, conservation. So conservation is just this idea that the total amount of energy that we have does not change. That energy cannot be created nor destroyed. It can just be moved. By moved, I mean it can be transferred or transformed, right? You're not just going to magically have energy. And a great example of this is when we look back and we think about our health unit, right? So someone asked me a question on Canvas last week. How does eating an apple get you to ride a bicycle? Well, let's think about it this way. We know that we get energy to move and to survive. We need energy to live. We get that from the foods that we eat. If I break it down even more, you might remember from that unit that the two foods that give us calories and energy would be the carbs and fats that we eat, while the proteins repair, right? So if we eat an apple, which is pretty much one giant carbohydrate, apples are mostly carbs. They're great carbs for you. They give you lots of energy. That is change in your body, right? That the way you take in that energy, it is all chemical energy in a way, not the type of chemicals you think of like what you clean with, but in the sense of like the atoms are really tiny and they're changed within your body, and then it changes to mechanical energy. So mechanical energy is any sort of movement happening. So you moving your muscles and your legs on a bike is the mechanical energy, right? And you're getting that from the apple you ate maybe an hour later that was transformed into mechanical energy as you output it from your body. So you intake the chemical energy from the apple and the carbohydrates. You output the mechanical energy when you ride your bike and use your muscles later that day. So we're never just, we don't just magically have energy, right? We have to get it from somewhere, and we're always using it. So yeah. As well as that, I want to point out that if you don't eat, right, and you probably noticed this before, if you don't eat enough, or you do something and you go for a run and you didn't eat breakfast beforehand, you might be really, really tired. You might feel like you have no energy. That's because you don't, because you need to get that energy from somewhere. This is just a little flashback to that last unit, but I think that's a great way to think about it, and that's how I think about it most, because that's what impacts me the most in my daily life. I'm constantly thinking about, well, if I'm going to go for a 5 mile run, I might want to eat something first, right? If I'm just going to watch Netflix all day, I don't need to eat as much as I would if I was going to go on a 5 mile run, because I don't need as much energy. Just a thought. Remember, transform, transfer, conservation. Okay? Have a great day.